And new streaming solution. So if you were here for last week's failed live streams, then apologies for that. We ended up changing the whole everything so that you guys have a better experience. Hopefully this one will work out. Fingers crossed. And welcome everyone to Shipyard Level 3. Congratulations for passing Level 1 and 2. Yeah, so if you made it this far, you know everything there is to know about Nym and the technology and the vision, so and also the economy. And now that you know everything, Level 3 is all about getting involved for those who want to. But I'm getting a bit ahead of myself because we'll explain what Level 3 is about in a bit. But first, let me introduce today's presenters. Today I have with me Jaya for that aforementioned overview of Shipyard Level 3. Say hi to the people, Jaya.
Hello, people. Very good to be here. Super happy to kickstart this final level of Shipyard. It's going to be very exciting. This is all about getting hands-on. So graduating from level 1 and 2 basically means you're prepared. You've got all the information and the training necessary in order to dive in and get involved. So we're going to talk a bit more about that in a minute.
Exactly. But before that, I also need to introduce the other presenter here today for the meat and potato of this session. I also have with me Chelsea Menning, who is going to give us a technical deep dive into hard drive optimization, if I can speak, for cryptocurrency, hardware optimization for cryptography-based applications, which is the area of R&D that Chelsea is leading at Nym. Say hi to the people, Chelsea. Good to finally have you on.
Hey, I'm glad to be here. Unfortunately, I am not where I'm normally at. I am in London, of all places. So I am greeting y'all from some flat in London. So.
Oh, nice. At least the time zone wise, this works out a bit better for you then, right?
Yeah, it's great. Yeah.
Amazing. Super excited to finally have you on. All right, and before we get into the level 3 overview with Jaya, as always, we're gonna have a Q&A after this session. So if you have any questions for Chelsea, Jaya, or myself, make sure to leave them either in the YouTube chat, or you can also, as usual, use our Matrix server if you don't want to log in with your Google account and compromise your privacy. So without further ado, Salazar, please bring on my screen. All right, so welcome everybody to Shipyard Level 3 once again. How this will go today is that I'm going to give you a general overview of Level 3 and also explain how it's different from Level 1 and 2, because it's quite a bit different. And then Jaya will walk you through the three tracks of Level 3, which you've already heard about: the Visionary, the Builder, and the Operator tracks. Yeah, so here's the agenda. Now let's start with the similarities. So just like before, Level 3 will also take 2 weeks in total. So it will start today and it will end not this Friday, but the next on the 17th of November. And after Shipyard, depending on the number of applications we get for grants and other stuff, we may take up to about 2 weeks to make a decision on those. Now, just like before, there are going to be a whole bunch of lectures, workshops, and other events scheduled for you to attend, but that's about where the similarities end. So basically, in short, level 1 and 2 were about arming you with knowledge, and then level 3 is, although you will learn things during level 3 as well, but it's mostly about putting that knowledge into practice and to help you get involved in the long term if that's something that you want to do. So like I mentioned before, during Shipyard is not a standalone program. It is the beginning of something bigger. So level 3 is where you start building towards that something bigger. And first, you will need to select your role or specialization for that. Now, Jaya will, of course, go into the roles a bit further and explain what they are about, but whether it's advocacy and community building and running Nym infrastructure or building stuff on top of Nym, level 3 has you covered. Now, we did make sure that there's no overlap between the different tracks in terms of schedule. So if you're a super duper hardcore, you can attend all of these, or you can participate in all of these 3 tracks at the same time. But if you take a look at the schedule, which will be shared on the usual shipyard.nimtech.net website, then you will see that if you choose to do that, then you would have like a super packed 2 weeks ahead of you. So good luck with that if you choose to do that, but it's very possible. Now, a big difference, the first big difference, is that this time around with level 3, there is no homework, and also there are no more exams either. Because while, like I said, you will continue to learn stuff over level 3, this is more about doing things than learning. So in that spirit, anyone can join, both individuals and squads, regardless of previous Shipyard participation, although participation, of course, will matter in different aspects of level 3. Now, another big difference compared to levels 1 and 2 is that, like we mentioned earlier, there's no direct Nym token rewards. So with the exams, we also get rid of the way we rewarded you guys for exams. Most of the rewards are more in the spirit of long-term collaborative rewards. So basically we have, as you probably already saw on our website, we have allocated a total of 1 million Nym tokens to go towards level 3. And this will go towards the best squad impact proposals and grant applications, both community and developer grants. These are, again, all in the foster spirit, in the spirit of fostering long-term meaningful collaboration. Now, 500K, up to 500K of these Nym tokens will be distributed this year as part of the direct grants that come out of level 3, and then another 500K will be distributed over 2024 for the outstanding squads and individuals. Now, on top of that, of course, there are going to be treasury delegations for the operator track. So we are going to be relaunching our delegators program, which you probably already know, which was a small-scale delegators program at first. We're going to be relaunching that. More info on that tomorrow. And the operator track winners will get treasury delegations to kickstart their successful node operator business. And I think with that, I'll hand over to Jaya, who will go into the details of each individual track. Take it away, Jaya.
Thanks, Sudo. I think you covered quite a bit already, but let's go in any case. Right. So as mentioned, the reason why we've got these 3 tracks is because a system like Nym actually has quite a few different roles, right? There's different ways to actually like realize the Nym mission of enabling privacy for all of humanity, more specifically enabling traffic level privacy for all internet traffic. So we've developed these 3 tracks. The visionary track are for people who don't feel like their tech skills are maybe quite up to date, but they are super interested in privacy. They want to advocate for privacy. They might be very good at producing memes, visuals, writing texts, coming up with new narratives in order to make privacy understandable and relatable to a broader public. And now the operator track is obviously focused on mixed node operators. So this is where, we're really trying to kind of profile some of the existing incredible operators that we've got and allow other people to level up their nodes to get a chance to join the active set. This is a super key track for us at this point in time because, as most of you probably know, we're launching the Nym VPN fairly shortly. And in order for that VPN to be successful, we need to make sure that there's high quality nodes operating across the world, and especially in the target geographies where we're going to be launching the VPN first. So get involved there if you want to learn how to start a successful node operator business and meet other node operators that have been quite successful over the past year or so. Then we've got the builder track, which is for people who want to kind of like tinker and start integrating the mixnet into either existing applications or building small mini apps themselves, or to improve the kind of tooling around Nym, right? So we've got some fantastic community members who've already been building a bunch of tooling and mini apps, everything from Paste Nym to Explore Nym, calculators for APY for node operators and that sort of thing. So we're going to be profiling some of the existing work that our community has been doing and enabling builders among you to actually take part in that. So to go a little bit deeper, the builder track mission for the next couple of weeks is to dive into this hackathon. You're going to learn all about the SDKs. The DevRel team, Alexia and Max, are leading this track. And the channels that most of this track is going to take place on is the Matrix dev channel. And you're going to want to look at the developer portal as well to get your head around what's going on. The best hackathon projects will be selected. This is towards the end of Shipyard. So everybody's going to graduate on the 17th of November, but there's going to be a couple weeks after that where the jury is going to look at everybody's projects and make a selection of which projects are the best ones. And the jury comprises, of course, Nym core team. Chelsea, we're going to loop you in to have a look at some of the top projects. Harry is going to join as well as jury, as is the head of the dev team, Mark. And we've got DarkFi joining us too. Next slide. The operator track here, the mission is to increase the quality of Nym nodes, the coverage of Nym nodes, and the amount of exit nodes, right? So as I mentioned earlier, this is super key to enable a well-functioning VPN. Our track leads there is Sarinko and Daniel, and you can reach them both on Matrix as well or Discord. And you can reach out to our fantastic community manager Merv on the Node Help Telegram chat if you want to get started with a little bit of extra assistance. And as Sudo already mentioned, people that are going to take the operator track will graduate to receive official delegations and level up their Nym nodes. Next slide. And then we've got the visionary track, which again, here the mission is mimetic victory, right? So let's make privacy go viral. This requires a lot of work on the narrative and on the visuals. Your track leads here are Mikola and Huxian. So reach out to them on Discord, or you can join the Ninja Cadets Telegram channel. Graduates from the visionary track, whether you graduate into the Ninja Ambassador program or form a squad with people from the other tracks. You can then from there on apply to community grants and impact proposals, as Sudo mentioned. So, we'll list obviously all the channels for the different tracks again in the chat. And the blog post that went out earlier today gives you an overview as well. And I think I'll leave it at that. I think we've kind of gone through the 3 tracks a few times over. So good luck, everyone.
Thanks for that, Jaya. Hopefully everybody's as excited as we are to finally kick off level 3. Now, with that said, I think it's time for us to hand over to Chelsea for her talk, which I'm really looking forward to. Salazar, can you please bring up Chelsea's screen? If she's already shared it. All right, Chelsea, take it away.
All right, cool. All right, everybody. So basically, I'm going to give a brief overview on the sort of problem facing any sort of privacy project that uses a lot of a heavy amount of computation. Whether it's an AI application or in this case, privacy project. So one of the problems that sort of happens whenever you're trying to do a lot of computation is that you have limitations imposed on you by the actual power and the size and the built-in functions of your hardware that run the software that you're trying to accomplish some kind of task on, be it a cryptographic task, an AI task, some kind of function. And so one of the problems that I've been sort of working on generally, and this is, I do very unstructured talk, so this is based, this is very much based on the kind of talks that I used to give for. Hang on. I'm looking at the tab here, but Jamboard is not playing along at all. It's not letting me draw anything. So I might not be able to show you anything from a drawing, I won't be able to draw anything on the whiteboard here, unfortunately. So I'll try at least to be able to write things. What is going on here? Seems to be bugging out on me. I'm just going to go ahead and close this tab and continue on with the talk. So basically, like you're essentially trying to take a message from Alice, you're trying to send it to Bob. And now the way that this typically works is you have your sender send a message or send their particular email or signal message or telegram message, and it goes across the network, and there's sort of a one-to-one connection, right? There's obviously HTTPS connection, which is a pretty simple public key encryption where both people share a key, their public keys, and then they exchange their public keys. And then there is a third party that authenticates the communication between the two people. So in this case, it's like for HTTPS, it's usually the HTTPS service. So it's very simple. It's fast. The vast majority, I'd say, probably about 95% of internet communications now occurs very simply between point to point. Obviously there's the network and the ISP like routes the connections, everything between IP addresses or whatever, but it's a pretty simple and straightforward connection from point A to point B, where Alice sends a message to Bob. One of the things that happens is that as you increase the amount of complexity, the amount of computation increases. So what happens for privacy for privacy tools like VPN is you generate another public key. So Alice and Bob, or in this case the VPN distributor, basically generates another public key. Alice, generates a public key for her VPN application, and then Bob doesn't have a public key, but the VPN the VPN service does provide one, so that way you can sort of protect Alice's information from being able to be shared with Bob. So Bob can't see where Alice's IP address is because it's behind the VPN. But the VPN service, it becomes the point of failure in terms of being able to protect your privacy, where the VPN service knows where Alice is because they've set up the service, they've set up a subscription and everything. And so you have this extra level of security with the public key infrastructure. Now, then, if you're going into something like, very famous Alice and Bob. Thank you. They're my favorite. They're my favorite analogical or analog characters for these analogies. But if you're trying to increase the level of complexity on this network, then like say with Tor, you have a Tor circuit. There's still only a pretty simple key exchange. Even though you've added extra hops to the service, all of those hops have shared their public keys with each other, and the Onion network, it used to be called the Onion network. They keep rebranding every like couple years.
Kelsey.
So this connection, Sudo, you're on the screen now.
Sorry to jump in on you like that. I could really use some drawings for this. Do you want to fix your? People are patient; they will wait for you. If you could.
No, it's not going to work. I know that it's not going to work.
Okay, sorry for that. Then just go on.
Well, I don't need the drawings yet. It's gonna get more complicated here in a second. So then we'll get the drawings out. So this is the final layer. So basically, you have the 3 hops. So you have 1, 2, 3 hops, and so you're moving your data across there, and everybody's shared their public key. But there's still only the exchange between a public key for the sender and a public key for the distributors or the nodes on the network, and the public key of the recipient. So the public keys, there's still only one public key that's happening. So essentially, you're limited for an entire connection. You're really limited to about a 5 or 6 computation, sort of situation with public key encryption. And public key encryption is complex. I mean, I can pull up since y'all desperately want to see something on my screen. It just bugs out. For whatever reason, the screen share for my app just won't let me move up on the screen either. So does it stop whenever? It does not stop whenever I close that. So this is a technical problem that I'm going to have to dig a little bit more into.
We can bring on your screen share if you just press the button down in the middle.
I did do that, and it bugs out on me.
Oh, there it is.
It doesn't do it. It doesn't do it for a PDF. So this is.
There it is. Now we can see your screen.
I'm stepping ahead here with the SGX information here, but let's just go ahead and move on to the sort of the the solution to large, to a very complex computation problem is to move all of these public key computations that are happening like on a pretty large scale when you get to like the scale of a Nym application, or if you're a service provider and you have hundreds of thousands of users, then you need something like an acceleration service. So what Intel has on their servers is they have this this acceleration. They have acceleration modules built into their industry grade chips. So obviously SGX is kind of has a bad reputation now because of some side channel attacks, which we'll get into. But they've upgraded it to TDX, which essentially has this very simple layer system where it is trying to develop. Oh my God, I'm not having much luck. I am getting my. Is it my mouse that's causing this problem? It is not my mouse. I think it's the screen share. I think the screen's causing my software to bug out. Yeah. It's the screen share.
I guess we have to get rid of it then.
Yep. I'm not going to be able to use the screen share. I'm going to... Oh, can you even see me? Oh, there I am. Hey, everyone. So sorry about the technical problems with the screen share there. Screen share never works for me for whatever reason. It's always some technical problem. I do want you to... Oh, my God. I do want you to pull this up if you can. What is going on? I think my entire computer's frying right now.
Sure, just send it to me. I'll put it on from my screen. That's totally fine. Just
I might. My laptop might be about to just like kaput. Just a heads up.
Oops.
Yeah. Some like I'm having some like layers of a stack of problems happen all at once. I'll be right back. It's gonna be a second.
Okay. Well, on that note, I didn't really prepare anything to entertain you guys with. I could sing, but I should probably not do that because that would be terrible for all of us. So I will just, I don't know, I could maybe recite some poem, maybe? Does anybody have a good poem? Or maybe a good joke? Jaya, do you have a good joke?
Hello. Hi.
Hey.
Well, I thought we could talk a little bit about Mikola's session, which is coming up immediately after this. I think that we've got a few people in that room already, no?
I think so. Yeah. Usually when we announce a Jitsi call, people just jump on the opportunity. So yeah, we're going to be having a session with Mikola, which is looking to be super interesting. It is going to be about advocacy, which is of course a big part of the visionary track in general. I myself am also going to be there, so make sure to join. It's one of those. If you've ever joined one of our Jitsi calls, it's one of those like more familiar, bit more up close and familiar vibe discussion. It's gonna be nice. Jaya, are you joining us?
I'll see if I can make it. We have the kind of all teams meeting, all hands on deck meeting as well at the same time, so I might have to give it a miss this time. But for those who don't know Mikola, he is part of the Nym core team, and he runs the ambassador program, which we also call the Nimja program. So if anyone's interested in becoming a Nimja, or generally just would like to support Nym in terms of advocacy and spreading the vision of privacy as the default, do dip into that session and you can meet people from all over the world.
I think Chelsea's back in the meantime. I was about to ask you a question, but then you're off the hook. So, Chelsea, are you ready to be put back on? Throw a thumbs up. There she is.
Not yet.
Hey.
Can y'all hear me? Okay.
Yes.
Hello. All right. So I bounced to the laptop, or I bounced to the to my mobile. Given all the stacks of problems I'm having with my laptop, all of a sudden I wasn't having these problems before. So that's how this goes with these freaking presentations.
Technology, right?
Yeah. Now I gotta put my phone into a spot where it's not gonna fall.
All right. So if you want, we can also do this another time. I think there's quite a few.
No. It's that we're gonna have the same problems regardless of where we do it. So.
All right. In that case, then I will take Jaya and myself off the screen, and you take it away.
All right. So we'll just go mobile then. I won't be able to see the chat, unfortunately, without. Oh, here we go. Yeah. People think it's like the NSA or whatever. I don't know. It's probably more likely that trying to do streaming still causes your devices to sort of fritz out. And so getting into like the problems with streaming, for instance, because it's actually related here. The amount of computations happening whenever you're trying to do a streaming codec, for instance, the way that it normally works is you would have a bit of software like FFmpeg try to do this kind of thing. Now then, it's the same thing with cryptography. Cryptography and a video streaming codec are essentially the same principle. You are encoding information into a particular type of information. Now it's decoded on the other side. So where you only have to do video once, you're taking live video information and encoding it once. But there's specialized hardware that enables you to do this. Now then, the specialized hardware options that we have. So Intel SGX and TDX is one sort of solution that has come up over the years. It's a hardware solution that has its history of problems, of course, but the Intel came up with this. Intel came up with this concept of doing what's called an enclave, right? And so a secure enclave is a really good idea in principle, right? It essentially takes your hardware and it creates an environment for your specific type of hardware. And so, and on the other end, on the server side and on the client side of another person, there's an end-to-end encryption from hardware device to hardware device. So without even having to like go through the typical process of having something hit your memory and go into your CPU completely bare metal, Intel came up with this principle of having having the encryption happen at the CPU level. So there's a CPU module that using the public key infrastructure. In this case, I think it's RSA. In their case, I think it's RSA. Uses this public key infrastructure to basically like ensure that every single packet of information that's coming through the entire infrastructure from Alice to the service provider to Bob is happening in an enclosed, secure environment. It's called a hardware enclave. And so this principle works in theory, but Intel's implementation of it was fraught with a number of problems, a lot of design problems and flaws. Can we trust in the hardware? The answer to that Intel found was no. So there was actually a side channel attack that happened to the infrastructure. This was a large implementation too. This happened like 5 or 6 years ago, where Intel went across this entire stack, basically like implemented a bunch of Xeon servers and this entire stack, and a stack of applications were built on top of it, like for a number of like server-side applications. And it turns out that there's actually a side channel attack that can happen. And so even though this idea works, the susceptibility to these side channel attacks and vulnerabilities is a challenge for security development. It is very hard to develop hardware, and the problem is that you can't really fix it. You can't just like come in and later on down the line and be like, oh well, we're just going to do a firmware upgrade, right? So whenever you have like a major problem like this, you're screwed. The entire system is compromised, and you've developed and baked all these chips and gone through the production process of developing this. And Intel invests an enormous amount of time and effort and hardware resources into developing these chips, which brings us to the next point. which is smaller developers, and then the idea of instead of using a massive stack or a massive developer, which is vulnerable to to making poor decisions, in its corporate decision making process. ARM and ARM came. So the ARM implementation, which is actually more efficient, allows for a bit more flexibility than Intel's like bureaucratic infrastructure. Which company's hardware do I trust? We'll get into that. So Apple Silicon actually tried to implement, and it has implemented, a very similar stack of tools as Intel's SGX. Apple Silicon famously implemented this on its M1 laptop, on its Apple laptop more recently. So it uses a secure enclave between its servers, yourself, and the local environment, and other Apple devices. And the secure enclave actually comes from the mobile devices, from the iPhone, and they switched it over whenever they moved over to the M1 chip and the Apple Silicon development stack with TSMC. They developed these system on chips, which is essentially a very different approach to computation, to like your day-to-day computer activities that you have on a desktop computer or a gaming laptop, for instance. So Mac has a system on chip that has a module, and one of those modules is a secure enclave. And so they use pointer authentication codes. Now, in the way that this works is that they have a specific module dedicated on their chip, right next to the CPU and right next to the GPU, which is, again, all on the same chip. And allows for the encryption and to occur entirely within the Apple ecosystem and entirely on your device. So your keys stay on your device in theory because it's baked into the chip, but your keys stay on your device whenever you enter. Whenever you have a generated key, whenever you have a randomly generated key for your which hardware company? That's Apple's Silicon. And this is developed at TSMC, which is the Taiwan, which is Taiwan's famous massive, chip development, basically like super center for making chips. They make, I think, like 40 or 50% of the world's chip supply comes from Taiwan at this point. But the stack of tools that Apple has built is a much better implementation of what Intel was trying to do with SGX. And Intel's coming along, and they're attempting to do the same thing with the TDX system. So TDX is a different approach to SGX. It's essentially redoing the entire thing to try to avoid what they had a problem with side channel attacks. The problem with which hardware features and companies is Nym compatible with? Working on that. So it's not compatible with really any of them at the moment, and we're going to get into that. So the next part is the problem with Apple Silicon chips is that Apple is very proprietary. They hide their information. They keep their information from you as from us as the developers, and from you as the consumer and as the user, right? So their stack of tools, while great and very secure, they do not allow for third-party observation of what's going on, unless you have like unless you have a electron microscope. You're not going to be looking at the security features on the chip. You have to essentially trust Apple. That Apple's very good cryptography team, by the way, is not making any mistakes or making any bad judgment calls in terms of its design in terms of its design. And that also prevents us developers who come up with more unique and more bleeding edge cryptography applications, such as zero-knowledge proofs. And in our case, there's the assumption, which has been made by hardware developers, that RSA is going to be a much more frequently used. That is a prime number based computation for public key exchange. Is going to be the most frequent thing that's used. Now, the good news is that for most applications, public key architectures and infrastructures do not require very many curve computations to happen. With Signal, for instance, which does not use RSA, it uses ECDH, specifically the 25519 curve. And so as this curve is happening, it doesn't require a lot of them. So usually you just use your local CPU on the CPU. You're not even using like a hardware security module on any part of any portion of any chip, and you're using that to build or to do your secure exchange of messages. The problem with this is that Nym does a lot of ECDH. There is a per packet key exchange, and per packet key exchange happens 3 times, once per hop. So for every single hop, there is an ECDH computation being done. So the thing that slows down Nym, but also makes it incredibly secure, is the fact that ECDH, that an enormous amount of ECDH computation has to happen. And so one of the solutions to this that we've sort of identified is that there are a number of open source implementations of hardware, architectures and development infrastructure, such as RISC-V, which is an open source architecture. It's the first open source architecture. So it is similar to ARM64 and ARM32 in its efficiency, in its implementation style. It's very different though in the fact that you don't have to pay a license to ARM for this. Like Apple pays a license to ARM. Android developers, when they're developing phones for various Android devices, they pay a license to ARM. With a RISC-V device, which I think like Huawei is like developing RISC-V devices now. So China's obviously getting the RISC-V development. It's obviously getting into RISC-V development. European Union is backing a lot of RISC-V development for chips. But these are general purpose CPUs, right? The architecture itself doesn't have a security module built into it or the assumption of one. But you can design and develop hardware security modules for using the RISC-V architecture, and you can vastly increase the speed and the scale at which you can do, and of course the security, because there's not one of the most secure ways to ensure that your communications is secure is to not use software which has a number of exploits which can happen. So think of it like this: whenever you have software, right? So you have tens of thousands of lines of code which get compiled into a binary. And that binary is written in assembly and was read by the machine. And there's a number of ways in which you can disentangle that and come up with exploits to that system, because like whenever it's running in software, everything can be visible by anybody on the device. It's in memory. If you can access that memory, if it's not secured properly, then you can essentially disentangle the cryptographic infrastructure or the cryptographic calculations that are happening, and therefore read the communications from within on the device. Now, using a hardware security module, it moves the computation into baked-in paths, right? So it instead of trying to do just simple computational math in CPU, you are now transferring that into a dedicated hardware solution. All right, Microsoft has been making strides in hardware-backed security with the Pluton chip. How does integration of cryptographic optimization contribute in enhancing overall privacy and practical implications? Generally, we're getting into this. I'm not terribly familiar with what Microsoft is doing. I know that they're up to something. I know that yeah, we're going to the physical layer, so to speak. So as we go to the physical layer, the communications the communications get secured in the most military-like manner, in the fact that your communications are happening, or your communications are being encrypted from point to point, and then it's actually the hardware which does the disentangling of that communication. So there's less possibility of side channel attacks and for timing attacks. For the actual cryptography, and also trying to grab things out of memory and try to, you know, get little packets of information and stuff as you're doing this across if you're going end to end and you're going across the network. So the problem with Nym is that you have to do this 3 times. So you have to go 3 hops, and we're using elliptical curve. We're using an elliptical curve cryptography. ECDH using curve 25519, and the problem is that there is not really a good way of doing this in any existing hardware security modules. So most hardware security modules, they prioritize AES, which is a great symmetric key encryption. It's the standard across the world. It comes in 128, 192, and 256 bit encryption types. And then there is RSA, which is I think like 10. I think it's 1024, 2048, and 4096 bit encryption, public key exchange encryption standard, which has been used basically since it was developed in the 1970s. The problem with elliptical curve, of course, is that it's not used very widely yet. So there are applications that use it, but don't have the level of intense application use for this as Nym does. So one of the things that I've been proposing for Nym specifically for this kind of situation is that since we're doing a scalar vector multiplication problem, which doesn't parallelize, so to speak. There's not really a shortcut to doing a lot of public key exchange using ECDH. So one of the ways in which we're sort of trying to come up with a way around that is that we are trying to parallelize that, with a large number of ECDH computations happening across the network. Now then, or across the hardware. So essentially you would, in theory, have a hardware security device, potentially using TPM, which is there's a TPM 2.0 module. And again, this hasn't been designed, this hasn't been developed, this is just a theory as it stands, but essentially take the most efficient implementation of hardware of doing ECDH at both ends and scaling that up so that way you are doing 100, 1,000, 10,000. So that way, as you are exchanging more packets across the network, you can essentially just sort of skip through that and come up with a way of putting all of these things into a buffer, sending it into the hardware security module, and then receiving them back, and then being able to just do this, whiz through these much faster than you would, if you had done this using the current implementation, which is a pure software implementation. So RISC-V mixed node when? We have to develop it. I encourage people to talk about this, to discuss this. I'm just giving the broad scope as to where things are today. We don't have this implemented, but the way to go about this, not just for Nym, but for all secure enclave applications, for censorship protections for privacy protections and anonymity across the network. Zero knowledge proofs. I didn't even get into the fascinating realm of zero knowledge virtual machines either. You know, that those are those are a little outside the scope of hardware, but they're related. ZK VMs are a fascinating approach to doing this kind of math and this kind of privacy. But we really need to come up with a cheap, efficient, and spreadable, so that mixed node operators can run them on their various devices and servers around the world and do this. Now there are a couple of approaches to doing this. There is the hardcore. There's hard mode, which is sort of the way that Intel or Apple Silicon does this, which is they have a system on chip, and they put their module and they bake it in, and they have a baked in, like in this case, I guess it would be an ECDH module, which would then be put into your Apple Silicon devices or on your Intel SGX or TDX, I guess in this case, or whatever X comes around 4 years ago. Yeah, Spectre, Meltdown, those are the side channel attacks. Specifically, Meltdown was what I was talking about with SGX. That was a pretty significant attack and vulnerability that basically compromised. Basically, you had to throw out all these SGX chips, even though companies really didn't, because they spent all that money on them. But going back to the hard mode. So the way that you could do this is you could have a hardware security module that does ECDH on all devices. But then there's easy mode, which is the approach that I'm sort of looking at, which is to develop either a specific ASIC, on a PCI Express like 4 card or something like that, or have an FPGA, which is even easier, since you can reprogram. Since it is hardware and it's dedicated hardware, it's a little slower than an ASIC because you are using a bunch of gate arrays. So you're essentially like instead of having something baked in with a lithography machine, you essentially have a lot of gates that can recreate the hardware environment. This is used a lot in like video game emulation. Like if you're trying to emulate allegedly emulate a Nintendo 64, for instance, then you would use an FPGA to develop that, or to emulate the environment, the hardware environment of that kind of architecture chip, like an old console. But we can do this for ECDH in theory. In theory, at least. And we're not even limited to elliptical curves. There are always new implementations of these things. There's a number of zero knowledge proof operations that are going to require FPGA development. And I know that there are other hardware developers, both in Europe and in East Asia, who are developing FPGA implementations of zero knowledge proofs. In this case, I think that the bottleneck for us is the elliptical curve computation. I skipped over myself a lot. I bounced around a lot. I got taken a little bit aback by some technical issues here. So I moved from my laptop to my phone. Let's get into questions. Hopefully, I will be able to send you all some links. I have a number of links that I'm definitely going to send you all as before we leave today. And I sincerely apologize for the technical stuff. I am traveling, so these things happen.
I mean, can we just stop and acknowledge for a second the fact that Chelsea, with everything breaking, just pulled it off like this? It was absolutely. It was really beautiful. It was really nice to just listen to you geeking out into a phone camera. It was beautiful. Absolutely lovely.
Great.
We have amazing community questions as well. I think maybe Jaya and I should address the ones that are for us. There's only 2 of them, and then we can get into the meat of it with Chelsea's questions.
Great.
All right, so Question from Nick is whether it's possible to take two tracks together, for example, visionary and operator. Quick one, yes, it is possible. Like I told you earlier, it is absolutely possible to participate in both, but it's going to be a brutal 2 weeks ahead of you if you do that. So make your choice smart.
I would add to that, it's like going to school, right? So, you know, like it is 2 weeks of packed activities if you take 2 or more of the tracks, but also highly recommended. I mean, you're literally going to be an expert, possibly even more so than some of the core team members by the end of it. So you're more than welcome to follow as much as you want. And that will actually qualify you quite nicely for the follow-up grants. So.
All right, next one, and this is also the last one, is whether this is from Tatiana. Thanks for the question, Tatiana. Question is whether only nodes that already exist or have already been set up qualify for the operator track, or new ones are also fine. I'll leave this one to you, Jaya.
All nodes are qualified. Having said that, we are going to have specific criteria to make sure that these are actually nodes that the VPN can make use of. So whether you've run this node for like several years or you've only just started up, you can absolutely apply to the Delegators program. But Danielle, Vasquez, and Serenko will go through some of the other criteria a little bit later this week, because we are going to require you to be running an exit node. And there are going to be, you know, specific incentives for specific geographies that are of importance at this stage of the network. So make sure to follow the presentations by Danielle and Serenko, and of course jump into the channels and ask them any questions directly as well.
All right, and those were the 2 questions for us. Now let's go over to Chelsea. First question to you, Chelsea. And sorry, community, I can already see that we're not going to be able to ask all of these amazing questions. So if you want to keep the conversation going, then jump on our Matrix server and in the general chat. Hopefully, Chelsea, correct me if I'm wrong. If they tag you, then you can answer the rest of the questions as well, right?
Yeah, but I also get tagged like 500 times a month. So.
All right. So be sparing with the tags, guys.
Yes.
All right. So the question is from Bikram. In a mixed hardware environment like a data center, how can cryptographic keys be efficiently managed across different architectures? Could you share an example of key management strategies?
TPM is, I think, the most is the most promising key management strategy right now. So essentially, there's been a move towards standardizing for TPM, which is essentially a module. I mean, if you've tried to run a video game in the last 2 years, or tried to install Windows 11, then you've needed to make sure that you have TPM2 installed and enabled on your gaming computer, for instance. This is the same thing on the server level, right? So you would have a module like a TPM, like a trusted, like this trusted compute module on there, which essentially holds the keys, generates keys, and manages it all in hardware. TPM, I think, is good. I think it's a move in the right direction, and I think, and I obviously applaud TPM. I think that TPM can be misconfigured and done improperly, and I think that there are ways in which, in the future, TPM modules could be designed and developed better. I think that, obviously, there's going to be a TPM3. I just don't know when. I think that it's hard to do on scale, and it's hard to do with different environments, right? You know, like we obviously had this problem with Intel. We had this problem with Apple, where they tried to do this. I think TPM is the most promising, but it's also the least future-proofed. It's essentially solving a problem that existed 10 years ago and is just catching up. Really, with the needs of the environments that we have. It's like running an EPIC chip, for instance, has been the solution, or a Xeon, which are the server grade CPUs, have essentially been the solution to this. Is essentially just have more CPU and have more memory before the TPM came along. And I think that the trusted modules, I think, are moving in the right direction, but obviously they're also not the end all be all to the solution.
Yeah, and it rings a bell to me that when Windows 11 came out, it was quite the fuss about the fact that it required a TPM module to be installed as opposed to Windows 10, right?
And it's good that they force people to do that. I know that it's frustrating, but having a TPM module is a good thing for your privacy. It's a good thing for your security.
All right, thanks for that. Now, moving on to the next question. You kind of already answered that, but I want to hear your riff on it a bit more specifically. So the question is from Papu. Thanks for the question. Which company's hardware do you trust? What companies work with the government? I think it's a really good one.
Yeah, you never really know which companies are going to be working with the government. The government has an incentive to obtain these kinds of this kind of information. I have. Anecdotally, I have heard that I've heard that certain companies have had particular problems in the past. I don't feel comfortable naming names here, but I generally think that most people in most situations are going to be just fine with an Apple device. And that's for the vast majority of situations. Now, there have been compromises. There's been evidence of like NSO group attacks and your Pegasus type attacks on mobile devices and on things but those are very targeted. I think that for the vast majority of security conscious people, Apple devices will do these kinds of things for you. I'm still skeptical of Android implementations that are software based, that use crypt setup, for instance, for its computation, etc. I'm not saying that Nym endorses Apple. I'm answering your question, by the way. I can see the look on Jaya's face. Like, this is not a Nym endorsement. I'm simply saying, based on my particular tastes and my expertise, that I think Apple devices are more secure generally, but I can't verify that either. So there's the verification problem, which is the fact that because they're closed source, we don't get to verify whether what's going on there. I don't have an electron microscope, so I can't double check that. But as trying to do my own security research, I have noticed that Apple devices have been the most difficult for even very sophisticated actors to break.
Thanks for that. Now, folks, I'm not going to ask multiple questions from the same person because we have so many. So I'm going to jump over to, I think this is going to be a quick one. And you also kind of talked about it during your presentation, Chelsea, but here it is. The question is from Anderson. Which hardware features companies is Nym compatible with?
Yeah, so which hardware features with companies? The answer right now is none, right? So there's no particular component of Nym that needs to run on hardware that exists as an existing hardware security module, right? There isn't really a part of it that I believe hits on anything unless because it's a Rust implementation. Basically, it runs pretty lightweight. It's very efficient. It's written in Rust. Obviously the validators are written in Go. They're compiled well. They're very efficient. They're at the bleeding edge of cryptographic of sort of the cryptographic software implementations. The really hairy part, though, I think, is going to be this idea of trying to do secure enclaves, which I think the Nym can be a part of a secure enclave type environment moving forward in the future. Say 3-4 years from now, if somebody wants to implement a system like that, using a RISC-V or something like that. But also, then we also need this hardware security module somewhere in the stack, specifically with the mixed nodes, that is able to do that's essentially able to do the elliptical curve cryptography on scale. That is not there. There is no hardware. There's no hardware that is available to us that is known to me that implements this to scale.
All right. Thanks for the answer, Chelsea. Please tag Chelsea, again, be sparing with the tags, but tag Chelsea on the general chat of our Matrix server, because that's unfortunately all the questions we had time for, because I have a hard stop at my 5 p.m. because I'm joining that aforementioned workshop with Mikola. So hopefully see you all there. Chelsea, huge thanks again for coming on. I will have one last question for you. Also you, Jaya, of course, as always. Let me share my screen for the usual outro. Now, the secret phrase for today is Moore's Law. So you can use it to claim your POAP in the same exact spelling. It will be shared in chat, and also the link where you can claim your POAP will be shared as well. Now, Chelsea, as it's becoming a tradition here on Shipyard lectures, I wanted to ask you what the relevance is of this term to your lecture.
Sure. It's the slowing down of Moore's Law that is our problem here. So Moore's Law, we've kind of reached a point where silicon-based chip manufacturing has peaked in its ability to, in its, we've sort of met physics, right? Where this was an economics problem, and now it's a physics problem. So now we have a physics bar, which is essentially preventing more transistors from being used. Now, the solution to that Apple found, and that more and more developers in this space, including Intel, AMD, and other ARM-based systems, is to use SoCs to reduce the distance between components and calculations and modules, because that's where the real bottleneck is. The bottleneck is already quantum effects and the speed of light. So it's directly tied to the fact that Moore's Law is no longer applying.
Exactly. Well, depending on who you ask, some people debate whether it does or not.
Oh no, it's done. It's done. There's no debate. The debate is done. I
do agree with you. All right. On that note, huge thanks again for coming on, Chelsea. It was an absolutely lovely masterclass.
Now there is ways around it. You can still get faster. You could still have computation be faster. I want to just caveat that. But in terms of like the original Moore's Law, which is the number of transistors in a particular space, I think we've reached that limit.
Exactly. Yeah. Maybe stacking, 3D stacking can sort of slow that down.
Absolutely. Yeah.
That's for another time for us to geek out on. Huge thanks again for coming on. Also, Jaya, and then I'm going to just quickly give you the rundown, guys, how to claim your POAP. As usual, you need to go to this URL over here, nymtech.net/go/POAP. A link will be in the chat, and use Moore's Law with the same exact spelling. But be quick, because this is only available for 15 minutes, so that only people who actually participated in this lecture get the POAP for it. Now, as for next steps, get ready for level 3. That's my first next step to you. So right now, actually 2 minutes ago, the Nym advocacy workshop is starting with myself and Mikola. So make sure to join that if you're interested in that sort of thing. Second, the operator and builder tracks will start tomorrow. So make sure to look at the Shipyard website with the schedule, and take a good look, because there's quite a few things. It's going to be a jam-packed few weeks coming up. So make sure to add the things that you want to attend to your calendar. Now, of course, the leaderboard for the stage 2 exam or level 2 exam is coming tomorrow. Hopefully you did well. Fingers crossed that you managed to pass the exam. And of course, yeah, here's the link to the level 3 site on our website. Once again, there's one separate page for each of the tracks. Make sure to check them all out, and maybe you can attend more than one event, or like more than one track at the same time. And with all of that said, I'm going to let both of my guests go, and I'm going to join that aforementioned work.
We lost Sudo.
Exactly. We did. Just in time. But I came back.
Good. I just want to say a couple of last things for people that are taking the operator and builder tracks. So the developer relations team, Max and Alexia, they're going to be having daily developer office hours. That's between 11 and 1 p.m. UTC. So anyone who wants to kind of dip in and just ask them a few questions, they're going to be on a call and available for you. So that's happening every day over the next couple of weeks. So please do take advantage of that. And again, you'll meet Sarinko and Danielle for the operator track tomorrow as well. Thanks, everyone.
Thanks for that. Have a nice evening, everyone, or day, or whatever it is in your region. Bye, everyone.
Thank you.